Hi, welcome to a video tutorial from RoboJax. In this video we are going to see how we can use this 4-channel relay with Arduino to control AC load or AC bulb like this. So we can control 4 separate AC load. The load can be bulb, it can be a heater, it could be a fan, anything that you want. You can get the code for this project by clicking at the link at the description, which will take you to robojax.com/learn/Arduino. A word of warning: if when you're working with AC that's now connected to AC power, make sure you do not touch this area or underneath, and make sure that this module is on a insulated surface like wood, plastic, something like that. If you're working, you want to adjust something or change something, make sure to disconnect the power from the outlet. This is the relay module, and we have 4 relay. That's why this is called 4-channel or 4 relay module. The relays, at this point we have 3 terminals for each relay, so these two. This and this terminal, as drawing shows, they are normally connected without power or anything. If I connect a power here, a light or a load, it will be connected. I'm using my multimeter as a continuity tester here. You see the sign, and when I connect these 2 probes, it just buzzes. I'm going to show you that this terminal, these 2 for this relay, these 2 terminals are normally connected without any power or anything, and these 2 are normally open. Same thing for this one and the other. This is normally connected without any signal. When signal comes here, then this and this pin will be connected. When you connect and use it, you always put one of the wire at the middle and the other wire, depending on your application. If you wanted the power to come when the signal comes to be disconnected, you just put it here because it's normally connected. And if you want it the other way, do not change anything about the middle one, just switch your wire there. And then here we have 4 terminals, we have 6 inputs. This is ground, GND will be connected to ground, and this is VCC will be connected to 5 volts. And then we have N1, N2, N3, and N4. So this is input 1, input 2, 3, and 4 for these 4 relays. So this is relay 1, relay 2, relay 3, relay 4. And the same way we have 4 LEDs here to show the status of these relays when they are activated. On this corner we have a jumper. Okay, so let me just put it to the jumper. You can either connect it. The jumper could be either connected or removed. When the jumper is connected, these relays will take the power from the 5 volts that you connect to this VCC, either Arduino or whatever. So the power will come and will be connected. But if you want to totally isolate this from Arduino, because sometimes due to high current and other reasons of connecting expensive equipment, if you want to isolate it, you can do that by removing this jumper, but you have to supply 5 volts separately by an adapter for this. So you see the buzz, and now let's put it. So this and this pin are connected. So remember that. The module length is 75.1 millimeter. 55.2 millimeter. The depth is 18.8 millimeter. This relay is low triggered, meaning that with the value of low or 0 volt, the relay will turn on at the input, and the value of 5 or high, the relay will turn off. So with the low, it will be triggered or will be turned on. So let me connect and show it to you. This is now the ground pin. I'm gonna put it on the ground here on this Arduino, and this is the 5 volts. I'm gonna put it at 5 volts. Now this has the power but does not have any signal to control. So I'm going to put this on a input 1. So now I'm going to connect this to 5 volts. As you can see here, nothing happened. Relay 1 supposed to turn on. Now if I connect it to the ground, relay is on now. So that is the meaning of low trigger. With low it will trigger and turn on, and with the high it will not trigger. So it's possible that you can get or buy high trigger, but does not matter. You can just adjust the code and play with this and make it work with any way you wish. I think that you remember for the relay, each relay has a rating. As you can see here, it says 10 ampere 250 volts, 15 ampere 125 volts, and 10 ampere 250. So it's 10 or 15 ampere. For a lower voltage in North America, it will be 15 ampere, and for the higher voltage in Europe and Asia, it will be 10 ampere with the voltage rating on the region. Calculate the rating of the power for the region. Let's say you have 240 volts, and then times 10, you can connect up to 2400 watt or 2.4 kilowatt in each relay. So each are independent. So 2400 watt in this one, 2400 watt in this one. But if you are in North America, then 120 volts times 15. So you can connect up to 1800 watt, 1.8 kilowatt of load into this. So if you do not follow the rating of this relay, the relay will melt down and it will be very dangerous. So make sure that that is the maximum. It doesn't mean that it continuously can handle. So make sure always leave some room for overheating. Let me explain now the code. So at the beginning we set number of channels. This program that I wrote can work with any number of channels, 16 channel, 20, as long as you have the right type of module. If you have Arduino Uno, you can go up to 12 channels, and if you have Arduino Mega, then you can go higher. So this 4 determines how many relay you have. And then beside that, in the relay array here, this is an array that holds the pin number for each relay. So this is the first relay, that's the second relay, that's the third and fourth. So it starts from left to right, and these are the pin. This is pin 2, pin 3, pin 4, pin 5, and then you put comma and then type other one if you have something like 8 or whatever, wherever you want to connect it. So for this case, we are just going, because I have 4, then I have 4 pin here defined. After that, this is the wait time, 2000 milliseconds, which I'm going to explain next, and then the I is needed for counting this to make it automated, because we don't want to write multiple code manually. We want to make it automated. After that, inside the setup, which starts from here and ends here, these are the important steps. First, we set the serial monitor to print this text for us, and remember this 9600 is the number that is on this corner, and they must match. And then we have a for loop which starts with I equals 0. I already have been defined, so I don't have to define it here. And then we say I is smaller than channel, or CH, which we have here. This is as if I type 4. So I is less than 4, which means it goes from 0, 1, 2, and 3, and then I increments. So when loop starts, this I is compared with this CH. I is now 0 compared with CH, which is 4. This is true now. I is smaller than 4. And then after that, it comes here and sets relay 0. 0 means the first value. And this is the 1, that's the 2, that's the 3. So 0, 1, 2, 3. So this is 0. So the 0 means 2. So pin 2 will be output, and then it goes pin 3, pin whatever 4, whatever value you have here, it will be set as output. And then we are also setting it as high, because the relay should turn off, and this is low trigger and high mean off. So we are setting it the same way as off. And after that we just print this text, which will be here. You will see it. This text is that. So this is the text being printed by this. And then we have a main loop which starts from here and ends here. Inside the loop I have two for loop, one here to turn the relays on, and then one here to turn them off. Now to turn them on, again I becomes 0, 1, 2, and then 3. So the value of I changes. So here this line just prints this text, relay 4 off. And remember here, because the value is 0, I have added 1 because we don't have relay 0. So 0 plus 1 is 1, relay 1, and then relay 2 is actually, this is 1. So we are adding 1 more to reflect human readable value, not 0, 1, 2. And then this, the same way as here, it turns the relay on, which means it sets it low and then waits for the amount of time that we set, 2 seconds. So as you can hear the clicks, each wait is 2 seconds. It turns on and then waits for 2 seconds and turns the relay, and the second relay on, and then the third relay, and then the fourth relay. After that, this does the same thing as the above. This time we are turning them off. Here they are low, which means on, and then high, which means low. So we are doing the 4 relays off. This is just for general illustration of how to use this, and because I wanted to use all 4 of them, I use this to show activity of 4 relay. But in your case, if you want to use it differently, for example, if you want to use it manually, so if you don't want this and you want to understand it, if you have trouble with the relay array, I'm just removing this. So remove it and put this. You can see that we have to put so many lines to do the same thing. So this is turning, when you put relay 0, it turns the 0 means this, and 1, 2, 3, and so forth. So it sets it as the output and sets it as high, and this one and sets it as high, and then relay 1. So this is for relay 2, and this is for relay 3, and this is for relay 4. So I'm gonna stay with this, and the same thing here. So if you want to turn any relay on or off, so do this. Inside the loop, just type here 1, that is the relay 2. If you type, so if you type 2, this will be relay 3, and then if you type 1, it will be relay 2, and so forth. So these are the relays that will be turned on and off. So you can control turn on the relay by setting this low, and turn it off by setting this as high. And you can set it under certain conditions. For example, if something is pressed, or some value of temperature is equal 65, then you can say this relay number 3 should be high or turned on. Else, if the temperature is not that, then turn it off. So you can do whichever way you prefer. The temperature is larger than 65, smaller than 65, or this is just an example, or any other value if button is pressed or something. So this should happen. Now let's look at the demonstration of this code. I've connected this AC bulb to the relay number 2. So this is relay 1, now relay 2 is now off, and relay 3 is off, and relay 4 is off. And then relay 1 will be on, and then 2 will be on. As you can see, the light is on, and 3 and 4. So all of these will be on. So there is a problem, however, that this now totally they consume about 250 milliampere, which is okay for this Arduino to supply. But if you want this one to be totally isolated, then we have to connect here external 5 volts for the relay, and this optocoupler or opto isolators are completely isolating the Arduino from the circuit. So I'm going to show you now. So I have 5 volts here. Now to connect it with 5 volts, first remove this, and once removed it, I'm putting the 5 volts, connecting it here, and this is a pin, the 5 volts. So the 5 volts, I'm connecting it, the pin on this side. This side already have the 5 volt which is connected to this wire, the VCC. So I'm putting it, as you can see, the relays are, the signal is coming but the relay is not working. You don't hear the clicks because they need 5 volts. Still, when I connect this will not work because I have to share also the ground with this circuit. So I'm connecting this ground and then plug it somewhere on Arduino. I have another ground here, extra ground. So now I've connected it and it's working, and at this time I have completely isolated the relay from the Arduino because the 5 volt is coming separately here, and 200 milliampere is a lot, so you can supply it from another source. And imagine if you have 16 relay, it will be under no circumstance Arduino can supply the current for all of these, because if there is only one relay, you have 70 milliampere. Each relay will consume 70 milliampere. Thank you for watching. This was introduction on how to use this 4-channel or higher relay using Arduino with AC load. So the code can work with any number of relays. Just make sure that if you're using a lot of relays and you want to isolate it, just make sure that connected here. So please subscribe so you can get updates of my upcoming videos, and also if you have any question, please post it in the description below. I'll try to answer it. Thank you for watching.